I'm Dean Zeller, and I've been mentoring 2 students this semester for FSI. I was an instructor last year at FSI, and it was a wonderful experience. I let my students choose their own project, and so Jessop here decided to do programming, and usually I teach an introductory programming class in which you learn a language. He decided that wasn't enough, and he wanted to further than that. So without any further ado, I will turn it over to Bill.
Hi, I'm William Jessop, and I'm here presenting my project today called Decoding. So like my mentor said, normally in one semester someone can learn 1 coding language. I decided that wasn't enough, and I decided to learn 3. So that's basically the basis of my project. So let's start off with a little introduction. So this project is about coding languages. It studies 3 main coding languages that are in relative abundance today. Python, which is one of the fastest growing coding languages that exist today. Java, which you can hear used in a lot of places. And then C++, it's an older language, but it's still used very commonly today. Just stuff that's used in a lot of places, stuff that a lot of people prefer to use for different operations in business and things like that. This project studies language in terms of 2 things, function and syntax. Function is what the language is able to do, which for the most part was the same across the board. Not any of these languages really have limitations into what things they're able to do, but then also studying them in syntax and how those languages represent those different tasks. So later on we'll see the differences in how you wrote an if statement in 3 different languages. It's not all the same across all of them, but they all accomplish the same operation. And this statement and this statement and this statement, but they all look a little bit different. And then also, all the languages that we're studying were found to have fundamental similarities, like I said earlier, just spread across the board. They all kind of have the same functionality across most of the languages. So what is a program? That's probably the most important question when you talk about programming languages. So a program is just a way to automate tasks. It's a way to feed commands to a computer so that it can interpret them and do something for you. So look at things like your word processor. You double-click the icon, it opens it up, it pulls up your document, and you can just start typing right away. It's a system of commands that were written in a coding language that allows you to be able to do that. It allows you to double-click that icon and it takes care of all the setup. Before coding, you had to go find a piece of paper and a typewriter, and none of that automatically formatted for you, and spell check was not a thing. So I'm pretty sure everyone's really happy for spell check. Other things like Google and any software company or people who make computers or iPhones or Androids, anything that has anything you can think of a computer chip has to run the back of some form of programming language. So then what is a programming language? A programming language is a medium in which you write this code. So if a program is a system of code that executes a task, the language is the medium in which you write that code in. So the programming language just gives you a structure to be able to take commands and express them so that you can perform certain tasks. Another interesting thing to mention, and we'll get into a little bit more later, is that there's a program that was developed called Compiler that takes commands in what we can write and converts them into what machines can read. So get into that here in just a bit. So what was the very first computer code? That's a very important question we have to answer when we're looking at analyzing programming languages. So the very first computer code that was ever developed was something known as the machine code. Now, whenever someone gets up here and starts talking about programming, the first thing that comes to mind is always 1s and 0s, and that's exactly what machine code is. It was written in a format called binary, where you have 8 bits. So you have 8 1s and 0s that all correspond to one thing. Either that being an operation, selecting data, saving data, naming any letter or any character, any number. That's all done in 8 bits of binary code. This code is incredibly easy for machines to interpret. This is how we store data today. We store the majority of our data magnetically in 1s and 0s. It's very easy for a computer to look at something, determine whether it's true or it's false, and then keep working in operations like that. So our computers today, they work in 32-bit, 64-bit processors, which means it can process 32 to 64 bits of data per second, 64 bits of binary every time it operates, so whatever the runtime of your computer is. So that was really important. But obviously, this is code that is not very easy to write. It is incredibly difficult for us to look at that and know about 8 times speed. It's virtually impossible. So obviously language needed to evolve. So the very first evolution in this was the very first programming language. The very first way to start simplifying the code was called the assembly language. Now, assembly languages consisted of 2 things. It consisted of the very first programming language where we were expressing commands in words and sentences, well, not sentences. We're expressing programs in words instead of numbers. And it also consisted of a very special type of program called an assembler. So basically, how this would work is that you would write the code that you see here on the left. You'd write that in English words, and you could come up with operations a lot faster. You didn't have to type 101 for add anymore. You can just type add. So it made things a lot more intuitive, made things a lot quicker to write, made things a lot less programming, because now instead of 1 digit being off, you can know add is spelled with 2 B's instead of 2 D's. It's easy to spot. It's very easy to tell when there's errors, or easier to tell when there's errors. But then the other part of the assembly language is what was called the assembler. This is basically a proto-compiler. It was written specifically for the assembly language, and what it does is it takes the code that we see on the left and converts it to the code that we see on the right. So how it does this is it binds each and one of those commands that we see on the left, it binds those to lines of binary that correspond. So what this program is doing is it's creating 2 variables, placing them as certain values, multiplying them, and then giving you the result. So that makes sense when you see it in assembly. I mean, you maybe cannot interpret that because it takes a lot of study to understand that language, but it's way easier to write in assembly than it is in machine. So, what does 8 times speed look like today? Obviously, programming has come a long way from what it used to be, and I'm very happy for this. So, today, I didn't have to write, 20 or so lines of assembly language. I had to write 3. I had to write 3 lines, and this is in programming language that I'll talk about more later. This is called Python. So basically what this does is it creates 2 variables, calls them as inputs. You can put in any 2 numbers you want, and it will multiply them and give you the result. So the way this does this, so that in modern day this is expressed through what's called a compiler. So it takes the code that we see on the left now and converts it into an example of binary like you see on the right. Basically what it does is it takes all of those and generates machine code to correspond. Programming languages became so simple that we can't one-to-one the lines directly. As you saw in the machine code program, there are probably close to more than 20 lines right there. And now we only have 3. So the compilers are very good at taking code that we write now and expanding it to the point where it's specific enough for a machine to read and read quickly and interpret correctly. So for this project, in order to study the differences and similarities, the strengths and weaknesses of these different coding languages, we needed to come up with a standard for comparison. And the first program that I wrote for this is called the Decoding program. Basically, what this program does is it asks the user whether they prefer ham or turkey and will provide a cumulative response based on what the user inputs. So this program studied the similarities and differences in Python, Java, C++ of the operations of an if statement and how those languages take user input as a whole. So you'll see in this next slide here, this is an example of this very same program, but in a 4th language. Now this language was something that I created after having studied the other languages, and this is called pseudocode. Pseudocode does not follow any specific syntax, which syntax is the way a language writes different operations. So it's not, if I were to try to compile this code, nothing would happen. It would give me a plethora of errors. It doesn't match all the way to C++, it doesn't match all the way to Python, it doesn't match all the way to Java. It's kind of more of a description of all 3 of them. So what pseudocode is it just describes all the logic chains that are behind it. So if we follow this program line by line, the very first line creates a variable, which is a string. When it's to a computer, a string is just a system, or it's or basically a word or within a sentence is what a computer interprets as a string. So it creates a string and names that variable the meat selection, right? So after that, it gives you a prompt. It gives the user a prompt that says, do you like ham or turkey? It's asking you for an input. So then it creates what's called an input. So it takes our meat selection variable and sets it equal to whatever the user inputs next. So if you input ham, then it will set meat selection equal to ham. So then what it does is it starts operating what's called an if statement. What an if statement is, it's a way of checking a condition, or it's a way of checking a variable against different sets of conditions to determine whether or not they are true. So if you take the very first line of the if statement, you compare the variable meat selection, and you compare it to ham. So if those two are the same thing, if the computer can tell that ham and meat selection are both the same thing, then it will run the next block of code. That line in the if statement was met, meaning it's going to not read the next statement, which is called the else if statement. It will just jump down to the next line, it'll go over the next indent, and run whatever block of code is there, which in this case, it prints welcome to the ham side with an evil smiley face, as though that is the favorable choice. So now, what if you go back to the user input, and instead of this time putting ham, you put turkey. It'll go through the if statement again. It will check to see if turkey is equal to ham, which it isn't, and then it will run down to the next line, which says else if. So every time you create another section in an if statement, you have to use the word else first, because that's clarifying to the computer that what was above isn't true. And then you check it to the next condition. So you write else, meaning was if what was above wasn't true, if here's your new condition. So if turkey is equal to turkey, or our variable is equal to turkey, it'll print what would make someone turn to turkey, as though that could be the worst possible thing that you could have answered in this program. So then, last but not least in this program, there's a catch-all called an else statement. What an else statement is like I said before, an else statement will only be run if all the conditions above are not met. So if we put in pickle as our input, we go through pickle is not equal to ham, pickle is not equal to turkey, and there's no more conditions after that, so we'll run the else statement and say, what are you doing with your life? I gave you a simple instruction, you couldn't choose ham or turkey. So that's basically what that program does. So that's a very topical program. The deli meat program, it's very topical. It doesn't explain very much in these languages. So we need to come up with something for deeper comparison. For this, I used a guessing game. So basically, it runs through, you pick the casual mode or the challenge mode, and then it says guess a number between 1 and 50, and then you guess until you get the right number. And it tells you whether you're too low or too high. So for this program, it studied if statement and user input like it did before, but it also studies the concepts of functions, classes, for loops, and while loops. We won't get to all of these, but most of them are explained in the next slide, which is the pseudocode description for this program. So I'm going to run through this one a little quicker because we already understand what an if statement is. We understand what a print statement is. So at the very top, the first thing we do is we create the class called GameSelector. Okay, so we create a class called GameSelector. Basically, when you create a class, it's telling the computer for the next set of code, this is going to be a set of functions that I'm going to want to be able to call later. So it just remembers that that's the name that you gave it, and we are able to call that up later. The next thing we do, in the next indent over, is we create a function called select. Now, what a function is it's just a block of code that you can repeat multiple times by calling it multiple times. So we run through, it prints the prompt. It says, welcome to the guessing game. Here is your option. What would you like to play? Then it takes your selection as an input and starts an if statement. So it runs through the if statement. If your selection is equal to casual, if you want to play the casual version, it'll run casual game.game, which is a class I defined up higher in the pseudocode. So it finds the class casual game and runs the function inside that class game. So then it will run the block of code that corresponds to running casual guessing game. So then it runs through the if statement. If your selection was equal to challenge, it'll run the challenge game. If your selection was equal to exit, it will run another special command for loops called a break statement. And what a break statement does is it just ends the loop. So we see here up at the top, we create the variable x, and we set it equal to 1, and then we have a statement called a while, which is a loop. So this loop is going to run as long as x is equal to 1. And so x is always going to be equal to 1, so this loop is just going to keep repeating. So if we don't want this code to repeat forever until we error the program, what we need to do is we need to include a break statement. So if you type in end, or if you type in exit, it will break the loop, meaning it will exit the loop, and since there's no more code after that, it will just stop. And then last but not least, there's another catch-all that just creates a valid collection telling you that you did something wrong. So for these three different languages, Python was the very first one studied. It uses the syntax of indentation to separate code blocks. So if we have a class, we indent once, or class, we indent once, and there's a function, we indent once. Here's the function description, go back to the beginning, and now we're in the main block of code again. Excuse me. It uses double equals for string comparison, like we talked about earlier. So if it's comparing your variable to a string, or if you're comparing your main collection to ham, it does that using double equals. And then it takes user input directly. It doesn't have to go through any loops like other languages have to get to that. The next language that was studied was Java. It uses braces to separate blocks of code. So it still uses an indentation just because that's how most people like to see code formatted and make it very clean looking. But when you write the if statement, you put a brace, and you put a brace at the end, letting you know that's the end of that block of code. This runs string comparison through a command called dot equals, where instead of using equals, it'll set your variable dot equals, which is just a way of letting Java know that you're comparing two strings, and you're not comparing an integer to a string, and then we'll compare your string. And then it takes user input through an object called a scanner. Basically what you have to do is you have to import an object called a scanner, and then call it, and then have it take input. It's kind of a roundabout way, but that's why it's good for object-oriented programming. Last but not least, C++ was studied. It's very similar to both languages. It uses braces to separate code. It uses double equals to compare strings, and it takes user input directly. But it also contains extra lines that don't make sense in terms of logic. Things that don't make sense to if statements, or while loops, or for loops, but are still needed to format code correctly. So that's examples like this: include line and this namespace line. That's just ways to simplify the code and to include libraries that the code is going to use, or include set the functions that the code is going to use on the computer. So basically, what I've done throughout this program is that I studied all three of these languages, developed a pseudocode that I showed you to demonstrate the program. I found that Python is a very good language for beginning programmers. It's very quick to pick up. It has simple syntax. You can just hop right in there and start programming, and you don't have to worry about syntax. You can worry about logic instead, which is what is more important when you're studying code. Java was found to be a very strong language for what's called object-oriented programming, where you set up all of your blocks of code as objects instead of iterative code. Iterative code just runs from the top to the bottom and reads everything that way. Object-oriented code creates classes as objects that can be called later, which is why the inputs have to be set up that way in Java. It's because it sets everything up as an object. And the C++ was found to be a very descriptive language. You can be very specific with it. You can get a lot more nitpicky with it. But it can also be a lot more difficult to write for that reason. You need to know what you're doing if you're going to write in C++. For my methods and materials, this was done on my Surface Pro 3, very simple computer, not a supercomputer. These different IDEs were used, like Idle, Eclipse, and C-Line. Most of this stuff is free. You guys can go online and look it up. I even did Python development on my phone. Go to the App Store, look for an app called Python Free, and there you go. You can start programming in Python. Last but not least, for my acknowledgments, first and foremost, I would like to thank my family. Hopefully you guys are watching out there. They have meant so much to me throughout this experience. They supported me so much, and I could not have been here without them. Next, I'd very much like to thank my mentor, Dean Zeller, for being able to help me go through and edit my paper and to get all this presentation the way I wanted it and things like that. Next, I would like to thank my sponsors, the Coos and Clark Western Foundation and the Bacon Family Foundation for sponsoring me as a scholar to be here and for sponsoring my research. To be able to conduct research into programming languages and be able to study how cool they are and be able to learn three of them in the span of 6 weeks. Last but not least, I would like to thank my mentor, Rabia Assad, for editing my paper and doing things like that for me. And I'd very much like to thank Lori Ball and all SSI staff members for supporting us through this camp and for getting us through for providing this wonderful experience to the RAs for being there for the dorms, providing whatever we need, and to all my peers for being able to put up with me throughout this whole camp and being very supportive in my projects and my classes and stuff, having help whenever I needed to go to it. So. Any questions? Matt?
So after working with all three languages, which do you prefer and why?
Personally, I prefer C++, which isn't common to a lot of people. People tend to prefer Python. Well, I mean, it's case by case, but the majority of people, I think, prefer Python because it is so simple. I prefer C++ because of the descriptiveness. I can be a lot more specific with what I want to do and what libraries I wanted to include and such. So for further development outside of this camp, I believe I'm going to be using C++. Elena.
Okay, so you said briefly about how Java is like an object-oriented stuff.
Yeah.
But so what are each language typically like? Which one?
Most of that depends on preference. That depends on how companies want code to be formatted, what they want it to look like so that other people can work on it. Pretty much, like I said at the beginning, most of the function of all this code is very similar. A lot of it can be done in pretty much all of these languages. There were earlier languages that were developed for specific tasks. Things like Fortran for science, and then COBOL is for business and stuff, but it's not that specific anymore. A lot of it can be overarching. If you want something more specific, there will be libraries you can use inside of those languages to accomplish specific tasks. Lori.
First of all, Kelly Jessop says, yay, now Bill has done a good job. And second of all, Lily has a question. How difficult is it to create your own programming language? Will, are you interested in creating your own programming language?
To answer that, yes, I'm very interested in creating my own programming language, basically just because I can. It can get very complicated very quickly, but there are lots of programs that have been written after this point to simplify this. For example, there's a program that was written called Compiler, which basically what it does, I talked about compilers that take your language and translate it into machines. There are now programs that write the program that take your language from it to machine. So it takes a lot of time and it takes a lot of effort to be able to get to the point to be able to do things like modern languages like Python and Java and C++, but it is possible, at least in proto forms. I don't know, just for however much time you're willing to put forth to it. Yeah.
So how do you select your three languages that you focus on?
I selected my three languages mostly on what I believe was commonly used. I selected Java and C++ because you think about programming, and those are usually one of those two is the first one to come to mind. C++ and Java are still used a lot today, and Python is one of the fastest growing languages that's been written. So ever since it was released, it hasn't been used a whole lot in professional settings yet because it is so simple. And for a lot of things, people want to be specific. For things like game design, you want to be able to tweak tiny little things like that. Python is growing into that market very quickly, and Python is also a very good prototyping language. If you're writing something that you're not sure it's going to work, something for like robotics or something, it's really easy to test it. It's just easy to write it quickly and then test it. So, Java or Maddie, whichever goes first.
So you said that there's a sheet code, the binary code that was very like the core of the game.
Yeah.
So like were there websites around that stuff?
Yes, the question is that everything pulls back to machine code and our websites run on that, and the answer is yes. There's just different languages. The languages are like JavaScript, which is developed for web development, and then things like HTML and XML. They're very, I can't say they're super similar. They're for the purpose of web development, and everything pulls back to binary code. Part I'm not quite certain what you're asking.
So you said that like machine binary code is the first thing, and then
Yeah.
it develops more and more into that way to think of words and stuff.
Yeah.
So like as it develops to like the
using this type of code to do out there?
The question was is that since machine code is language keep getting more developed, I believe the answer is yes. More advanced languages are being come up with every day, so we're getting closer to being able to use full context, which means we're able to type a sentence and then have the machine interpret it and be able to extrapolate it, but it's very difficult to do that because you can type one sentence, but like if you type Romeo and Juliet, the computer knows that it's two people on, or Romeo and Juliet on a balcony. It knows that it's two people on a balcony, but it can't make the connections without the Shakespearean play and all the emotion associated behind that. So code is developing, but it takes a lot of time, especially to get to the things that are broader. So when you start broadening the definitions of what machines can do, it keeps getting exponentially harder to write. So
kind of is on programming, the language is getting not much but evolved.
yeah.
And so, what programming language do you personally think is the best to use?
The question was, what programming language do I think is the best to use right now? And my only answer to that is it really depends. It really depends on what you're trying to do and how you want to accomplish it. So much of it overlaps a lot anymore. Like, I mean, the only thing that I will say is that you can use web development scripts to develop websites. That's about the only thing that I can think of. Like, if you're doing anything else, I mean, you can honestly interchange C++ and Java and Python and do the same thing in all three of them in relatively the same amount of time to write that code. So, I wouldn't use Java to develop a website, but I wouldn't use HTML to develop the guessing program that I have. So, the VDAP.
You use SPSS program for specific tasks. So how similar or different is Python to SPSS?
SPSS, the question is, how similar is the statistical software SPSS to Python as a programming language? And I would say that they're very different. SPSS is closer to Excel. Because it's all put in, like, it's all put into data tables. Python is all written in code.
Let me rephrase the question. So how similar or different is Python in terms of statistical analysis as compared to SPSS? Because I think Python can run several critical analysis, right?
Personally, that's not something I got into. The question is, what statistical analysis can you do with Python? And I don't really know. I didn't have the time to get very advanced into these languages, but I do know that there are languages that are better for that. And that's another library thing. There will be languages like R and SAS that have more languages that are suited for statistics instead of programming. I feel like Python is just a little broader of a language. You have to go find a lot of plugins or build the algorithms specifically to be able to do that, which isn't impossible, but I feel like it's redundant for some of the other languages you have access to.
All right.